Let's look at some example problems. A student prepares a solution of CaCl2, or calcium chloride, by adding 0.55 grams of calcium chloride to a 500 milliliter volumetric flask and adding distilled water to volume. The first problem asks if the solution will conduct electricity. Okay, this has to do with the properties of calcium chloride when it gets dissolved in water. Calcium chloride is an ionic compound made of the metal calcium and the non-metal atom chlorine. Okay? So when you add calcium chloride to water, it, like all ionic substances, will ionize or break into its ions. Since calcium's in group 2 and a metal, it will break into Ca plus ions. Chlorine will gain an electron and form Cl minus ions. Okay? So you will have all of these ions floating around in the water. And because they're ions, they can carry a charge. So yes, the solution will conduct electricity because it's an ionic solution. Okay? So let's do some calculations. If the student prepared the solution by adding 0.55 grams of CaCl2 to 500 milliliters, okay, in order to solve for the concentration of Ca2+, first we're going to solve for the concentration of CaCl2 of the whole thing. And then because there's one calcium ion per CaCl2, or per mole of CaCl2, the concentration of Ca2+ will equal the concentration of CaCl2. So if we can solve for this, we can substitute in this. However, first we're going to need to know the concentration of this, because this is what we added to the flask. Okay? So our known is that we had 0.55 grams of CaCl2 and 500 milliliters of water. What we want, or what our unknown is molarity, which is in units of moles over liter. Now, whenever we have grams and moles in the same problem, we're going to need molar mass of CaCl2. So we know exactly how many moles of CaCl2 we added. Okay, so to find molar mass, review. We go to the periodic table, we see that calcium has a mass of 40.08 and chlorine has a mass of 35.45. We only have one calcium, but we have two chlorines, so we multiply them out. And when you do that, you get 40.08, 35.45 comes out to 70.90. Add them up. 7, 8, 9, 10, 11. 1,110 grams per mole. Okay. So let me make us some room over here. We don't need the periodic table anymore. And I'm going to switch colors now that we have everything we need. Okay. We know we're going to do a dimensional analysis problem starting with what we were given. Okay. We know that we had 0, 0.55 grams of CaCl2. Okay, so let's go ahead and convert that to moles of Ca2+. Okay, because that's what we're going to need to know. So we set up a dimensional analysis problem. 0.55 grams CaCl2. Okay. We use the molar mass to convert it to moles. For every 1 mole of CaCl2, we had 110.98 grams CaCl2. So that grams of CaCl2 and grams of CaCl2 cancel out. That will leave us with how many moles of CaCl2 we had, but we want moles of calcium. So for every 1 mole of CaCl2, we had 1 mole of Ca2+ ions. Okay, that cancels out. That cancels out. And when you solve it, you get 0.55 times 1 times 1 divided by 110.98. 0.00495. We want to keep it to 2 significant digits. So we're going to say we had 0.0050 moles of Ca2+. Okay? But we want the molarity, so we need to divide that by how many liters we had. So we had 500 milliliters, and then we know that for every 1 liter, there's 1,000 milliliters. So that the milliliters cancel out. 500 divided by 1,000 simplifies down to 0.5 liters. Okay, so divided by 0.5 liters. And when we solve that all out, we get 0.0050 divided by 0.5, 0.0110 moles per liter. Okay? And that is our answer. That is the concentration of Ca2+ ions in the solution. Okay. Let's look at another problem. A student prepares a solution of CaCl2 by 1.5. Okay, it's the same one. We already know from our last problem that the concentration of, that's not it. Oops. Okay. We already know from the last problem that we had 0.005 moles of CaCl2. Zero point zero zero 0.0050 moles of CaCl2. Okay, but for every 1 mole of CaCl2 that was added, you get 2 moles of Cl minus ions because there are 2 chlorines in each mole of calcium chlorine. So what we have to do is there are 2 ways we could do it. We could set it up the same way. We could do 2 we could do 0.0050 moles of CaCl2 for every 1 mole of CaCl2, we get 2 moles of Cl minus. Cancel out. 0.0050 times 2 means that we have 0.010 moles of Cl minus ions. Divide that by how many liters we had, which is equal to 0.5 liters. And you get our concentration to be, when you plug it into your calculator, 0.10 divided by 0.5, a concentration of 0.020 molar. And we can check our answers to see if that makes sense. We expect our chlorine concentration to be double that of our calcium concentration, because when we added the CaCl2, we got 2 moles of chlorine for every 1 mole of calcium. So if we had a concentration of 0.01 for calcium, we would expect it to be double that for chlorine, which it is. Okay? So in order to sum up, our concentration in this problem, our concentration of CaCl2 was equal to 0.010 molar, which means that our concentration of calcium ions was also equal to 0.10 molar, and our concentration of chlorine minus would be double that at 0.020 molar. Okay, because it's ionic, all of it will dissolve, so these hold true. Now, if it were covalent or another thing that didn't dissolve completely, this would not necessarily be true. But because it's ionic and it does dissolve completely, this right here is the answer. Okay, cool.